Today, today is the last lecture of paper 22 version of P2 MCQs to May-June 2024. Okay, if you have not understand the previous lectures of lecture 1 and lecture 2, in which I have solved question number 1 to question number 27, then you can see on the right corner of the screen I button. Click on that button, then you can easily find out the whole playlist of all the yearly past paper. Okay, now let's start our remaining question answers. First of all, look at that. Wire X and wire Y are made from the same metal. The table gives information about the two wires. Wire, where basically there are two wires, X wire and Y wire. The length of X wire is 1 meter, cross sectional area is 0.40 millimeter square, and resistance is 2 ohm. The length of wire Y is 1.3 meter, cross sectional area is 0.30. You have to find the resistance of wire Y. So for that purpose, we have to solve this by using formula. Resistance is equal to rho L by A. Resistance is equal to rho, I am writing here as rho L by A. This is the formula here. Rho represents the specific resistance. Okay, the reason is that the value of the rho will be same for both wire, because both wire are made up of same material. So I will solve this question on the Word file. The reason is that it is little bit lengthy. Wait, I have to open any one. Just wait. Okay. So rho R is equal to, I will write here the symbol of rho. If I found it, I will easily, definitely, yeah, this is the rho L by A. Okay, we have to modify this formula just like that. R1, because we have two wires, and so we have to differentiate it. R1 and A is on the right side is in denominator. You have to multiply this on left side. Okay, so it will be equal to A1. Now divided by length is multiplied by rho, and when it comes to the left side, it will be divided just like that. Okay, is equal to rho, is equal to rho. Control C is equal. Okay, so for both wire are made up of same material, that is why the value of rho will be the same. So in that case, I will write it here. I am writing all the situation how to make a formula to solve such type of questions. So that is why lecture will be little bit lengthy. So you have to show your patience. Okay, right. Look at that. Left side, right side of both the equation is same. So by comparing both equation, you can make the formula easily. Okay, is equal to Control C, Control. Is it clear? Okay, now put the value of this one. The value of R1 is, I am writing here, the value of R1 is 2 ohm, cross sectional area is 2.4, and length is 1. Okay, the value of resistance is 2, multiplied by cross sectional area is value 2 multiplied by cross sectional area 0.4 and divided by length is 1 is equal to, you have to find the value of R2. So you have to repeat it here, multiply by area of area of the second wire is given here. You have to look at that 0.3 and length is 1.3. 0.3 and length is 1.3. Okay, now to multiply by this one, you will get here 0.8. Okay, and multiply by 1.3 is in denominator. When it will come to the left side, it will be equal to 1.3 divided by 0.3 will be divided on the left side. In this way you can easily find out the value of R2. Now I have to multiply this, then you can easily understand 0.8 multiplied by 1.3 divided by 0.3. So your answer will be 3.466 ohm. Okay, but you have to check the options. Yes, our D option will be correct. If you round off this 3.46, you will get 3.5 on it. So you have to remember all the scenario, how you can easily make a formula according to your demand. Is it clear? Now, this question is very important, that is related to potential divider. The question is that the diagram shows how, two resistors used as a potential divider. The reading of the voltmeter is 1.8 meter. This is the voltmeter. The voltmeter always used in parallel to the electrical component across which you have to find the potential difference. Okay, what is the resistance of the resistor R? Remember, when you look the word potential divider, it means you are using resistor in series, because the series circuit of resistors always used as a potential divider. Okay, the supply you have applied is 3 volt, and 3 volt is divided into two resistors that are connected in series. Look, remember the situation, you have to understand the situation. Total voltage is 3 volt, from which 1.8 volt is used by r that is represented by the voltmeter 1.8. Okay, so 3 minus 1.8, you will get 1.2 volt. The 1.2 volt will be used by 5 kilo ohm resistor. Okay, what is the resistance of resistor R? Now you have to find the value of this one. I am repeating that total potential you are applying is 3 volt, from which 1.8 is shown by this voltmeter across R. You have to find the value of R, and 3 minus 1.8, you will get 1.2 volt. That 1.2 volt is will be used by the 5 kilo ohm resistor. So we are going to the word file, then you can easily understand the. Okay, second question is, so the formula is V1. You have to write on the base V1 divided by V2 is equal to R1 R1 divided by R2. This is the formula. Okay, this is the formula of potential divider. Basically, this formula you have to remember this formula, just like that. The potential across the resistor will be directly proportional to the relevant resistor. Okay, so in that is why v1 is directly proportional to r1 and v2 is directly proportional to the r2. I'm not giving you whole details. When I will upload the lecture, then you can easily understand. Now, look on the diagram. Potential difference across R1 resistor is, I have gave you the hint. Hint is that 3 minus 1.8, you will get a value 3 minus 3 volt minus 1.8 volt, you will get 1.2 volt. This is the value of v1. Okay, so this is the main key point by which you can easily solve the question. And the value of v2 is, it has mentioned here 1.8, so you have to write 1.8 is equal to the value of r1 is 5 kilo. Look on the option, kilo is also used, so you must use only 5 here. Okay, just like the 5 kilo only divided by r2. You have to find the value of r2. That is why you will write here only r2. Now rearrange the formula, then will easily get then you will easily get your answer. Now, if you arrange this formula, you can find 5 kilo multiply by 1.8 divided by 1.2. Okay, now I will multiply all 5 multiply by 1.8 divided by 1.2. You will get 7.5. 7.5 kilo ohm. This is your answer. Okay, so look on the option. This one, C is your right answer. It is very simple. You have to only remember the formula and how to solve the situation. Okay. Now, look, next question. Two electrical appliances are connected to a main supply. The cable connected to one appliance includes an earth wire. The cable connected to the second appliance does not need an earth wire. Why is this? Is the reason for this difference? It is a very simple question. The question is that we have two electrical appliances. Both are connected with the main supply. One appliance is has a one appliance includes earthwire and second one has no any earthwire. Why is it so? Earthwire is mostly used in such type of electrical appliances where there whose uh, body is made up of any metal case. Okay, the reason is that if due to if there is accidentally attachment of your wire, damaged wire with the body of the electrical appliances, and you unfortunately touch with that appliance, then you will get a shock. Maybe you can be seriously injured. Okay, maybe you will be moved towards death. It can happen. Okay, but on the other hand, the appliance which are not which don't have any earth wire, it means their body is not made up of metal case. That is why earth wire is not required. Okay, so one appliance has a metal case, to whom we are connected the earth wire, but the other does not. So a option is the correct option. Okay, basically earth wire is used as a safety elements to save yourself from shock or any short circuit. Now, next question is, this question is very important, that is related to electromagnetism and Faraday's law also. I will give you the right here hint, Faraday's law for your understanding. Faraday's law. I have given you the hint here. Faraday's law. Faraday's law says that the EMF is induced in a coil due to the change of magnetic lines of forces in that coil. If there is no change in magnetic lines of forces, then there will be no EMF in that coil. Okay, so look on the statement. The statement is that the diagram shows a simple AC generator. The magnet rotates around a fixed coil wound around a fixed iron core. The electromotive force EMF output is a sine wave. Okay, a series of crust zeros and troughs. The magnet is shown in three positions P, Q, and R. During its rotation, the magnetic field in the coil is zero at Q, but changing must rapidly. Remember that the question is that you are using this is the diagram of AC generator. This is the fixed coil around that is wound around the iron core, soft iron core, I think. And this iron core is surrounded by the magnet, and magnet is if you look on position P, Q, and R, there are three position of magnet in which magnet you can see the position of all the magnets, and you have to identify in which position you will get the more EMF, and in which position you will get the less EMF. Okay, which statement about the induced EMF in the coil is correct? Okay, remember, look at this situation. When the magnet is in that position, it means magnetic field lines are coming out from the north and entering the south pole constantly. There is the reason is that uh, the magnetic field lines are uniform in that position, that are uniform and parallel to each other. That is why there is no change in the magnetic field lines. Okay, so there will be uh, no EMF, maybe a little bit smaller EMF in that situation. But when the magnet is rotate, as a result, it get new position, that is Q. Due to the rotation of that magnet, the magnetic lines of forces that are passing from the coil will be changed. So when magnetic lines of forces will be changed, so then according to Faraday's law, EMF will be induced in the solenoid that is shown in front of you. So when magnet rotate from position P to position Q, you can say that EMF will be larger in Q position. Okay, uh, so you have to check the option, which one will be the correct option. I have to remove all these things. No, now look on the options. The magnet or magnitude of EMF at position Q is larger than at the position B. Yes. Is it correct? This is the correct option. As I have told you that in P position, there is no change in magnetic field lines. So according to Faraday's law, induced EMF will produce only when there will be change in magnetic field lines. Okay, the change is produced when magnet rotate and moves towards the Q position. That is why in this position, EMF will be larger as compared to P. So your option will be P. Okay. Now, third question is, uh, of 24-volt power supply and 100% efficient transformer are used to light a 6-volt 12-watt lamp. This is the power of the lamp. Okay, what is the current in the power supply? the transformer is 100% efficient, it means input power must be equal to output power. Uh, the question is you have to find the input current that is supplied to the transformer. Okay, look on the solution. 24 volt is okay. Now solution is that input power is equal to output power, because it has mentioned in the question that transformer is 100% efficient. It means product of primary current and multiply by what happened here, multiply by primary voltage. Okay, now is equal to output power is, look at the question. Output, the lamp that is working is 12-volt lamp. We did not require 6 volt in this situation. This is used to this 6 volt can uh, disturb the students. The reason is that this is not involved to solve such type of MCQs, because it has mentioned the 12 volt. But in input situation they have give you the input voltage, and you have to find the input current. Okay, that is why in output side you will not use I and B. You have to put the value of 12 watt of lamp. Okay, input current you have to measure, it will be repeated as it is, and uh, value of voltage is 24 is equal to 12. Now 24 will be divided on the other side, you will get 0.5 answer in ampere. So your answer will be 0.5 ampere. Look on, yes, first option will be your answer. Okay, it is very simple question. Now move towards the 33 question. The scattering of particles via thin gold foil provided scientists with evidence for the nuclear atom. Which particles were scattered by the gold nuclei in the thin foil? This question is related to the Rutherford experiment. Rutherford used alpha particle that falls on the gold foil. As a result, uh, they identifies some features of atom that at the maximum part of the atom is empty, and alpha particles were collide with the dense material uh, that to whom therefore called a nucleus. Okay, so this is the detail of the, I have given you a hint of that experiment, but you have to understand in the lectures. So your option will be A, because they use alpha particle uh, on to fall on the gold foil. Now next on the 34 question is that a nucleus has 17 protons and 18 neutrons. What is the notation? Remember, X is for general term, X and Y are mostly used for general element symbol. Okay, and proton always shown on the lower side, and here 18 is a neutron number. But when you show the notation of any element, then we use atomic number and mass number. We never use neutron number here. Okay, the sum of proton and neutron is atomic mass. I will write it, atomic mass is equal to sum of proton number, and sum of neutron number. Okay, so proton number is 17, and neutron number is 18, you will get 35. You will get 35. So your notation answer will be D. Okay, this is your atomic mass, this is your atomic number. So this is your correct notation to show the uh, element. This is the correct notation of any element. Atomic mass is used on upper side and atomic number is shown on the base side, right, left bottom corner. Now, this question is related to the half-life. The dashed line on the graph shows the decay curve recorded from a sample of a particular radioactive isotopes. The count rate includes background radiation. Which curve shows this corrected count rate for that game? The question is that you are given this is the graph of any specified radioactive isotopes, and the count rate also include the background radiation. The background radiation is that the radiation that are coming from the atmosphere, from soil, from leaks also. Okay, so background radiation remains same of that place where you are performing the experiment. If you are performing the experiment in a lab, then maybe background radiation will be 10, 10, 10, 10. If you're performing in another place, maybe it can be vary according to the place to place. Okay, so account you are performing this graph is taken in a lab, obviously, and it also includes the background radiation. The question is, you must select the correct count rate. It means you have to remove the background radiations count, and then what will be the reading. So when you will subtract the background radiation, then the curve will be down uh, from this value to, remember, it will be just like that. Okay, it will be just like that. So we have to look on the options. I have give you a little bit hint. Look on the option. Yes, if you look on A option, when you subtract the background radiation, the plane line should be bottom. But in that case, it is showing that your count rate is increased. No, when you are subtracting something, the value should be decreased. But this graph shows the value is increasing. So this is wrong option. If you look on that, yes, this is correct option. The reason is that when you subtract background radiation from the uh, count actual count, then you will definitely move bottom of the original curve. So this is your correct option. But look on C and D. When you look on the C, the curve is going to match on this side. On this time, it means you are again counting the background radiation. You are again adding. So this is incorrect. In the same way, uh, both lines are going to meet. It mean background radiation are again counted in such scenario. So these are the wrong option. Only B option is correct option. Okay, so move towards the question number 36. Which type of radioactive isotope or radioactive source is suitable for the use in measuring and controlling the thickness of the paper in a paper manufacturing factory? Uh, so first option is type of emission and half-life. The question is, you have to use any radioactive material that by which, with the help of that radioactive source, you have to the measure and control the thickness of the paper in a manufacturing factory. So we must use such type of material whose uh, half-life is longer. Okay, if half-life is longer, then it will be used for long time. So we have two options of longer hair. First is this one, second is this one. And short half-life will be wrong. Okay. So now we have to select the radioactive source which will be more suitable. Then you have to understand, then you have to recall the properties of alpha, beta, and gamma. Alpha particles is stopped by the paper, so it is not suitable to measure the thickness. So only beta particle have penetrating ability to pass out through the paper. That is why we will select this option. Okay. Now move towards the next question. Next is a medical tracer is used to investigate a tumor in a patient. The patient has, uh, you have to investigate the tumor. The graph shows the corrected count rate from the tracer against the time. This is the graph of that tracer uh, whose atom are decaying just like that. This is whole scenario they have shown in front of you. You have to find what is the half-life of the soul. It is very simple question. Half-life means the time when half number of atoms has been decayed. Okay, actual count was 10,000. Half of 10,000 is 5,000. You check to check the time period of 5,000. Move horizontally and check where it will cut the curve. So we obtaining such dot. Move toward vertical downward and check out the value that is 2. It means your half-life is 2 minutes. It means your medical tracer in 2 minutes will be half. Okay. So your option will be A. Next is from space physics. The Earth orbits the Sun once in approximately 365 days. The average radius of the Earth is 1.5 into 10 raised to the power 11 meter. What is the average orbital speed of the Earth? So it is very easy question. The question I will solve it here in front of you. The formula is V is equal to V is equal to 2 pi. The value pi multiplied by 3.14. 3.14 multiplied by r. R is the uh, radius or orbital radius divided by time. Time is 365 days, but answer is in meter per second. So you have to convert these days into seconds. In one day we have 24 hours. In 1 hour we have 60 minutes, and in 1 minute we have 60 seconds. So you will get, I have to I have to put the value of radius also. I will write 2 multiplied by 3.14. Value of r is 1.5 multiplied by 10 raised to the power 11. I am going to write here by pen 10 raised to the power 11. Okay, divided by 365, 24, 60 and 60. I will solve it. 365 multiplied by 24 multiplied by this one. We will get 3.15153 into 10 raised to the power around about 1, 2, 3, 4, 5, 6, 7. 10 to the power 10 raised to the power 7. Now we have to multiply these three terms and divided by this one, then you can easily get your answer. 3.14 multiplied by 1.5, okay, and divided by 3.153. You will get 2.99. If you round off this, you will get 3. Okay, so b is equal to 3 multiplied by 10 raised to the power 7. 11 minus 7 will be equal to 4. So your answer will be a, or this is the 4 meter per second. So you will get a option. Is it clear? It is very simple, and I have solved that question in a very suitable way. Now, second last question is that which statement about the half-life of star is correct? About the life cycle. Life cycle of star will be it depends upon the fuel. Okay, it is very simple. All the star eventually run out of hydrogen as a fuel. When they consume all the fuel, then they will move towards the death period of its lifetime of its life. Okay, so A option will be correct. If you look on the D option, no. Uh, my protostar basically the starting of the stage. It is not the ending of the stage. So A option is correct. Now A option will be your answer. Move towards the next question. Last question. It is related to the Hubble. Hubble is very important topic. A galaxy at a distance of 3.1 into 10 raised to the power 21 kilometers is moving away from the Earth with the speed. This one, what is the Hubble constant H naught, and calculated using this data, and what is the speed of a galaxy at the distance kilometer from the Earth. So you have to understand the what is the value of Hubble constant. It is the constant value. You have to remember its value is in the range of 2.3. Okay, we have two options here. Now you have to understand which one will be the correct option. These two options are wrong. Okay, because in Cambridge book they have written the value of Hubble constant. Speed of light, uh, I will solve it on the word file. Speed of galaxy, recession speed of galaxy, remember V is directly proportional to the H naught, H naught. Multiply by distance from the Earth. D. Okay, this is the formula. You have to find the V is equal to the value of Hubble is 2.3 multiplied by 10 raised to the power minus 18 minus 18 multiply by distance is given a, that is you have to find, yes, at a distance of 6.2 into 10 raised to the power 21 kilometer. The answer is in kilometers, so you should note the place kilo as 1000. Okay, you use kilometer as it is. 6.2 10 raised to the power 21. 6.2 10 raised to the power 21. So multiply 2.3 multiply by 6.2, and from minus 18 plus 21 you will get, I will write here 14.26 multiply by 10 raised to the power 3. It means it will be equal to 1000. So multiply this one, you will get 14.26 14,200. So your answer will be around about this one. Okay, so your option is this one. So our lecture is ended. Now I will upload a lecture of P23 of P2 IGCSE Physics to May June 2024. If any person want to take online classes, then you can easily contact by my phone number. This phone number is given in description, and subscribe this channel and share this channel with your friend to get free of cost whole lecture of IGCSE physics. Okay, so uh, goodbye.